This is Mr. Anderson for Kellogg Community College, and we're going to be taking a look at some problems from Chapter 3, Section 2. The title of the chapter is Solving by Substitution or Elimination, and this is from the 9th edition intermediate algebra book by Bittinger, Bittinger, and want to just do a couple of these. I'm going to do problems 13, 17, and 49, and this is from pages 164 to 165 if you have a book. And if you don't have a book and want to learn a little bit more about some tricks for substitution and elimination method, just stick around. I'll be doing 3 of these with you. I will write the problems out here. This is problem 13. This is 3x plus 5y is equal to 3, and then we have x is equal to 8 minus 4y. Now, the book at this problem says you may choose the substitution method, and that would be the best one to choose since one of your variables in these 2 equations and 2 unknowns is actually isolated. The x is all by itself in the second equation. So take whatever the x is equal to and plug it in for that x in your top equation. So that will give you, 3, sorry, a little mistake there, 3 times the quantity of 8 minus 4y plus 5y equals 3. So 3 times this quantity of 8 minus 4y, that's, instead of the x, I put in what x is equal to, and now we have an equation that has one a variable in it, so we're going to distribute and then collect like terms and then solve for y. This gives me 24 minus 12y plus 5y equals 3. Combining like terms here, 24, this negative 12 plus 5 is going to be negative 7y is equal to 3. Using the inverse operations, we're going to subtract 24 from both sides. Negative 7y is equal to negative 21. Dividing both sides by negative 7, y is equal to 3. Now this is only one part of our 2-part answer because we have to actually figure out what the x-coordinate is. So we're going to take that y equals 3 and plug it back into the second line. The second equation, 8 minus 4 times y, is now going to be multiplied by 3. So x is equal to 8 minus 12, and x therefore is negative 4. So our answer for this problem, number 13, is negative 4, 3. Problem number 17 starts out with this equation, and again this is still under the subheading of you may solve using substitution method, which I think is appropriate here because in this equation you can see that I have the 2x minus 3 is equal to y. So since my y variable is all by itself, I'm going to circle it and I'm going to substitute that in for y. So that gets plugged in for the y, so my top equation now is written as 4x minus 2 times the quantity of 2x minus 3 equal to 6. We're going to distribute, then simplify by collecting like terms, and then solve for x. 4x is minusing 4x, and then we add 6 because the negative 2 times the negative 3 makes a positive 6. Now the 4x minus 4x, if we collect the like term, that makes 0, so 6 is equal to 6, which is a true statement. If I subtract 6 from both sides, I will get 0 equals 0. So in these situations, what we have is we have a problem that is a dependent problem, because there's actually one line being written in different forms that has a consistent answer, and that consistent answer is the set of all x and y values that correspond to one of these 2 lines. And I'll just write the top one just because. 4x minus 2y is equal to negative 6. If you wrote the bottom equation, that would be completely applicable because these are both the same lines. It's just written in a different form. So for our final answer, or our final problem I want to do with you today is, and I'll do it 2 different ways, because in this section, problem 47 says, use whatever method you want. And what's kind of, I'd say kind of nice about problem 47 is because the way that the book has it written, with A's and B's instead of X's and Y's, what's nice about it is that it's not real clear as to which method you should use. Because it's not a true substitution problem because one variable isn't all by itself, nor is it an elimination problem because the variables are not stacked, on top of each other. So let's approach this problem one way on the left side of the screen, and on the right way we'll approach it another way. And you can see that both methods get you there. It's just that your preference may decide which way you choose to do it. Now, either way, folks, we're going to be probably manipulating the bottom line in these two equations. So the first way I'm going to eliminate this, or the first way I'm going to manipulate this, is I'm going to get this set up since the b is almost by itself. I'm going to get the b all alone and set that equal to 3a minus 3, and then we have a substitution problem. We can take the 3a minus 3 and plug it in for the letter b up there in the first equation. So a minus 2 times the quantity of 3a minus 3 is equal to 16. We're going to distribute the negative 2, and then we're going to collect like terms, and then we're going to solve for a and b. So here we have a minus 6a plus 6. That's important because negative 2 times negative 3 is positive 6, is equal to 16. Negative 5a, because 1a minus 6a is negative 5a, plus 6 equals 16. Subtract the 6 from both sides. Negative 5a is equal to 10. Divide both sides by negative 5. A is equal to negative 2. And this is one of our two answers. What we're going to do is take that negative 2 and plug it back into the equation that's written right here, because the b is all by itself. B is equal to 3a minus 3. So what I'm going to do is plug the a into that. So here's 3 times the negative 2 minus 3. So b is equal to negative 6 minus 3. So b is equal to negative 9. So our answer for this problem is negative 2 comma negative 9. Now I'm going to show that again, but in this case I'm going to take this equation and manipulate it so it looks like a stacker equation. And what I need to do is just change the way that this is written in the basement here. I need to take the 3a and subtract it. I need to take the 3 and subtract it. So really the 3 is going to get moved over here by subtracting 3. And the 3a is going to move over here by subtracting 3a. So what this is going to give me is a minus 2b equals 16 over negative 3a plus b is equal to negative 3. Now in elimination, we try to multiply one or both of these lines by some scale factor if I need to get an opposite pair. The scale factor of this top, I'm going to keep it the same. I'm going to multiply the bottom line by 2. So I'm going to drop this equation down. So a minus 2b is equal to 16. I'm going to drop this equation down, but multiply it by 2. By multiplying by this scale factor of 2, this doubles in size. And now, when I add these together, and I choose to get opposites just because when I add them they cancel or simplify to make 0, then this will give me an answer of 5a, and that should seem a little familiar over here. These simplify, and this gives me an answer of, negative 5a, thank you, and that should seem a little familiar over here, and this gives me an answer of 10. Now, at this very moment, since you can see that I now have an analogous situation where negative 5a is equal to 10, so this entire process down here is going to give me a is equal to negative 2. But you might notice that, well, if I'm going to try to find my b value, and I did all my work over here, where am I going to plug my negative 2 into? And you plug that negative 2 into any of the equations up here, and for fun I'm going to plug it into this equation, this b plus 3 equals 3a. If I plug that into that equation, I get b plus 3 equals, and again this gets plugged in here, negative 6, subtract 3 from both sides. B is equal to negative 9, which is what I have here. So the way that you do the problem is really your choice. I'm always a fan of elimination, as it's a better problem when you're dealing with more than two variables, as we will deal with x, y, and z in section 3.4. But again, it's kind of your choice as to which method you use. And if the book suggests a method, try to follow their advice. All right, well, thank you for watching.